So today we will study about the strength of the beam section or the flexural strength of the various section. In the last videos we have derived the bending equation sigma b upon y equal to m by I equal to E by R, and we know that bending stress sigma b is equal to, we'll take y this side, divide by your I, m upon I by y, that is m by z, where z is said to be your section modulus. That is, the moment of resistance will be equal to sigma b into z. Now from this equation we conclude that the bending stress is directly proportional to value of y. That is, y is the distance of the fiber from the neutral axis. So if the distance is maximum, we will get the maximum bending stress, and at the outer fiber we will get the maximum bending stress. Next is, bending stress is also proportional to your bending moment and your moment of inertia. That is, bending stress, it also depend upon your section modulus. If lower the value of section modulus, high will be your bending stress. Or we can say that the moment of resistance will be equal to m into sigma b into z. That is the moment of resistance of any beam, or we can say the strength of any beam under the given bending stresses. It is directly proportional to the value of the z, and the value of the z, it depend upon the moment of inertia, that is the section of the beam which we are taken. Now in the last class we have discussed about that if there is a simply supported beam like this subjected to certain load, there will be bending in the beam, and we will draw the bending moment diagram. Do bending in the beam, the fiber above neutral axis are in your compressive stress, lower fiber will be in your tensile stress. Clear? Now we will try to find the section of the beam that will have the maximum stress. The various sections of the beam, side view, it can be your square or rectangular section, a circular section, or a I section, or a channel section. All these sections are your symmetrical section because they will divide the given section into two equal parts. Therefore, the value of y above and below is same. The value of y above and below is same. In this case, if this dimension is same as this dimension, then only these two value will be same. So these are said to be your symmetrical sections of the beam, whereas trapezoidal section, I section, U section, they are said to be your unsymmetrical section, which means that this distance above neutral axis and below neutral axis will not be same. So in this case, your neutral axis and central axis will coincide, and in this case your neutral axis and your central axis will not coincide. In order to understand which section of a beam has a maximum strength, we have taken three sections. A beam of I section, this is I section, 80 into 160, this dimension is 80, this is 160. Has a flange, these two portions are said to be flange, these two rectangles, and this rectangle in between, this is said to be the web. So this has flange and web thickness 10 mm, which means that this thickness is also 10 mm, this is also 10 mm, and this thickness is also 10 mm. We will compare the flexure strength or simply the strength of these three sections, and we will see that which section has a maximum strength under the condition that all these three will have the same area. And in case of rectangular beam, we will take that your depth d will be twice of the beam. This ratio we will take, and this is your solid circular, this will also be having the same area. That's why I have given the dimension of only the I section. So first of all, let us find the area of this I section. This area of I section will be, it consists of three rectangles. One is 80 into 10 plus, so this 10 and 10 minus, this will be 140 into 10, and this will be again 80 into 10. So the area of the I section will be equal to your 3000 meter square. Now we find the moment of inertia about the x-axis. Now in this case, the moment of inertia about the x-axis will be simply calculated by taking that this I section is being subtracted from a rectangle. That is, it has been removed from a rectangle of side 80 into 160. Therefore, the moment of inertia of this I section about x-axis will be equal to moment of this rectangle will be 80 into 160 cube by 12. That is 80 into 160 cube by 12. We will subtract this portion and this portion moment of inertia. So this portion will be your, this total is 80, 80 minus 10, 70, and this will be your 140. That is 80, that is 70 into 140 cube by 12. So this is the moment of inertia of this I section about the x-axis. Similarly, the section modulus z will be equal to moment of inertia about this axis and y. We will take y in this case, it is symmetrical, that is half of this, that is 80. So the section modulus of a I section, it come out to be 1,41,250 millimeter cube. So this section modulus, will define the strength of the beam. So next we have taken the rectangular section. B is the width, D is the depth, this is the neutral axis. Again, area will be B into D, but we are taking the rectangular section of the same area, that of the I section. So B instead of D, we will take 2B, 3000, and by substituting the values of D as 2B and simplifying, we will get B as 38.73 and D as 77.46 millimeters. So these are the dimension for the same area of a rectangle. We will find the moment of inertia, that about x-axis BD cube by 12. This comes out to be this much. And the section modulus Z will be equal to your moment of inertia about central x-axis divided by your y, and y will be half of this distance of outer fiber from the neutral axis. So this come out to be your 38,730. Whereas in case of I section, it was 1 lakh something. Whereas in case of your rectangular section, this comes to 38. So which means that the strength of your I section is more for the same area as compared to your rectangular section. Now we will take your circular section. By the same, if we take the same area of a circle is pi d square by 4 equal to 3000 mm square. The diameter come out to be 61.8 mm. The moment of inertia about x-axis will be equal to pi d 4 by 64. This comes out to be, this is the answer. And the section modulus, in order to find section modulus, the y will be d by 2. So section modulus z will be equal to ix upon y. This comes out to 23,172. Again, less than the rectangular section. So which means that for the same area, the section modulus for I section was 1,41,250, rectangular section 38, and circular section 23,000. If we take the ratio of Z1 by Z2, that is I section upon rectangular section, it is 3.647, which means for this case, your I section is 3.647 times stronger as compared to rectangular section for the same area. Similarly, if we take the ratio of Z1 by Z3, it will come out to be your 6.1, which means that for this case, the value which we have taken here, for this case, your I section is 6.1 times stronger than your circular section, which means that of all the sections which we have discussed, rectangular, circular, I, of all the section, generally I section of the beam are generally preferred because they will have the maximum strength of that section, I section, and because of the maximum strength of this beam, it will be able to withstand the maximum forces.